perhaps even more interesting than finding the inverse of a matrix, is trying to determine when an inverse of a matrix doesn't exist or when it's undefined. And a matrix, a square matrix for which there is no inverse or for which an inverse is undefined, is called a singular matrix. So let's think about what a singular matrix will look like and how that applies to the different problems that we've addressed using matrices. So if I had and I'll do a 2 by 2 because that's just a simpler example, but it carries over into really any size square matrix. So let's take our 2 by 2 matrix, and the elements are A, B, C, and D. What's the inverse of that matrix? Well, this hopefully is a bit of second nature to you now. It's 1 over the determinant of A, 1 over the determinant of A, times the adjoint of A, and in this case you just switch these two terms, so you have a D and an A, and you make these two terms negative, so you have minus C and minus B. So my question to you is, what will make this entire expression undefined? Well, it doesn't matter what numbers I have. If I have numbers here that make A defined, then I can obviously swap them or make them negative, and it won't change this part of the expression. But what would create a problem is if we attempted to divide by 0 here, if the determinant of the matrix A were undefined. So A inverse is undefined, if and only if, and in math they sometimes write it, if with two F's. If and only if the determinant of A is equal to 0. So another way to view that is, if a determinant of any matrix is equal to 0, then that matrix is a singular matrix and it has no inverse, or the inverse is undefined. So let's think about in conceptual terms, at least the two problems that we've looked at, what a zero determinant means, and see if we can get a little bit of intuition for why there is no inverse. So what is a zero determinant? Well, in this case, what's the determinant of this 2 by 2? Well, the determinant of A is equal to what? It's equal to AD minus BC. It's equal to AD minus BC. So this matrix is singular, or it has no inverse, if this expression is equal to 0. So let me write that over here. So if AD is equal to BC, or we can just manipulate things, and we could say if A over